All right. So the basic idea, right, is there are a lot of problems with the US electric grid supporting the data center build out at the scale that Silicon Valley wants to build out. And so the idea that's become very, very prominent is we don't need to connect data centers to the grid. We're just going to build data centers with co-located power generation, and then they won't be on the grid, and then we won't need to use the grid for data centers, right? And I think right now, according to the report Jigger sent me last week, there's 56 gigawatts of these co-located data centers in the queue.
People who have lost their goddamn mind.
Data center power plants would use 5 times more electricity than New York City. 46 data centers with a combined capacity of 56 gigawatts plan to build their own power plants. They would use 5 times more electricity than New York City. Why?
Yeah. So look, I guess like my hot take, right, is that my best guess is 80% of those projects won't get built, right? And so like
because 20% of them are so dumb that they're just going to finish the project.
No. Look, I think they're all right. So the way to think about this, right, is the thing people miss is putting a power plant next to a data center is like 20% of the work, right? The hard part is the power electronics. So like the way to generally think about this is it's the difference between building a power plant and building a utility, right? That's the difference between building like a natural gas power plant and a co-located data center. A co-located data center is its own utility, right? And the hard part is in the middle, right? And so when you think about like, I guess the best way to like summarize this is like data centers are essentially like power electronics divas, right? They have all these like weird quirks and weird characteristics, and they have inrush currents and harmonics and these fast ramp rates and like non-linear current and all these like crazy electrical characteristics that make it really, really, really difficult to load balance locally. Right.
All right, I'm going to quote you in your paper that you sent me, which I know has not been published, but we might have to force you to publish it. You say, when people say we need more electrons, what they're actually saying is we need more short circuit strength, more reactive support, and more tolerance for fast ramps. What does that mean?
Yeah. So essentially, what you're talking about here, right, is you put like a data center is essentially a shell that hosts these GPUs, right? And how GPUs behave in a training capacity is something that candidly everyone is still learning about, right? But what the initial data shows is that some of the power characteristics of these things are crazy, right? So they'll go from like using 5 watts to 1 watt in a millisecond, and the system has to be able to respond to that. So if you connect data centers to the electric grid, which is how we've connected data centers to the electric grid forever, that's the only way we build data centers until recently, right? You benefit from the inertia of the grid, which means you can have these like momentary lapses in frequency or harmonics or inrush current or whatever the case might be, and the grid will backstop you.
And that's what you mean by short circuit strength.
So the short circuit strength is basically that if the data center has a generator on site, right, and that gets out of phase with the data center characteristics, it'll force that generator to shut down, right? It'll have a short circuit trip and it'll force that data center to shut down. If you're connected to the grid and you have that same system characteristic happen, then the grid has the inertia to be able to backstop that problem so you can keep the data center online. So ultimately what you're talking about is system uptime, which matters a lot to the data center providers, right? And so like stepping back from this, the high level way to think about it is building a co-located data center is a massive power electronics challenge. Now, the reason I think 20% of those 56 gigawatts of planned projects are going to get built is because there are companies that are good at doing this, right? So like my former company, Scale Microgrids, can build co-located data centers. And Sheldon Kimber at Intersect Power can build co-located data centers. And like the Crusoe guys can build co-located data centers, right? So the question of like, is it possible to build co-located data centers is yes. Is it a good idea is a different question.
All right. So the next thing I'm going to quote you on is you say, But co-location is not a hack around the grid. It is the decision to become your own utility, not just in ownership, but in technical obligations. The grid interconnection point is not merely a wire. It is access to an infinite bus, a massive system that provides voltage stiffness, frequency stability, high fault current, and an ocean of inertia. When you step behind the meter, you don't just change who owns the electrons, you change the physics of the power system.
Correct.
All right.